Hello everyone, welcome to this video. Today we're going to look at the quotient rule. And so this is sort of the follows on from the product rule. So just a reminder about how you recognize sort of what you're supposed to use here. So if you've got a function inside of a function, then you use the chain rule. If you've got a function divided by another function, oops, that's what we're doing today. My brain was skipping ahead. If you've got a function times another function, that's the product rule. So product meaning multiply. And then if you've got a function divided by another function, then we use the quotient rule. And that's what we're doing today, finishing off these three rules of differentiation. And so if you've got a function divided by a function, like we have here, like we'll get to there, some function of x divided by another function of x, then we need to apply the quotient rule. Now, with the product rule, it didn't matter which order we did things in. Like, when we wrote down u and v, it didn't matter, but this one it does. So I'm going to sort of give you a tip for this one. And so if you follow the process that I use, then you don't need to remember this rule, but students do mess this rule up a little bit. They get the negative the wrong way around, and the incorrect v and that sort of thing. So let's just have a look at it now, and I'll show you my method so that you sort of never stuff things up. Okay, so firstly, just like with the product rule, I'm going to get you to write down u and v. So u is my top line, so that is cos 3x, and v is the bottom line, and so that's 2x squared plus 7. Then we're going to do our derivatives. So u dashed, okay, so cos 3x, cos goes to negative sign, and then there's going to be a 3 out the front as well. So that's going to be negative 3 sine 3x. There's my derivative for u, and my derivative for v is just 4x. Okay, so I've got my u, my v, and my derivatives of both. And so what my suggestion is, my little tip or trick here, is you do a little tick, right? So you do a tick like that. And that tick, if you write it out as u, v, u dash, v dash, the way I have, and you do a tick like this, that will just remind you about which order you're supposed to do them in, okay? So you do the tick diagonal first, you multiply those things together. So you multiply that by that first, that's v times u dash, that's the v times u dashed up there. And then you subtract the that times that, okay? So you do it in that order, and the tick sort of just helps you remember that. And the start of the tick there, that start of the tick there, that reminds you that it's v squared. That's what goes on the bottom line as well. Okay, so that's just a sort of a little trick there to help you remember which order to do things in when you're using the quotient rule. So let's do this now. Let's go and write down our derivative. So therefore, dy dx is equal to, so I'll multiply those ones together first. So I've got 2x squared plus 7 multiplied by negative 3 sine 3x. And then it's going to be take away cos 3x and then multiplied by 4x, which is the derivative of v, all over v squared. So where that tick starts, that 2x squared plus 7 squared. So that's just following that formula that we had. So you see how that tick just helps you with the order, what comes first, what comes second. If you get it the wrong way around for this one, then you'll get the wrong answer because it's negative. But with the product rule, it didn't matter because it's plus. It doesn't matter if you swap things around because of the commutative law. Okay, so there we go. Can we simplify this big monstrosity? Maybe a little bit, but not really. It's not. There's nothing that's jumping out to me that might simplify. I might just take that negative 3 out the front of 2x squared plus 7 sine 3x. I mean, don't really have to. It's not. You can't get a whole lot simpler here. Minus 4x cos 3x. Yeah, there's nothing that's jumping out at me as being helpful here, and we'll leave that bottom as it is. And so we'll leave our answer like that. Hope that makes sense. That's how we use the quotient rule. Let's have a look at a more complicated one here. Okay, so this is probably about as hard as you get in methods. So of sort of just nasty sort of grossness. All right, so again, let's write down our u, which is log ex, and let's write down our v, And I'm going to, anytime I've got square roots or anything like that, I just immediately change them to powers. When we're differentiating, it's just a lot easier. X squared plus 1 to the half. Okay, so that's what's on the bottom line. So therefore, my u dash is equal to 1 over x. That's the derivative of log ex. And then v dash is equal to, the half comes down the front. X squared plus 1 stays the same on the inside. Half goes down to negative half. And then we multiply it by 2x. So what we're doing here, we're doing the quotient rule, but we've just performed the chain rule within here. So that half comes down the front, and that half goes down to a negative half, and the inside stays the same. And then we multiply it by the derivative of the inside. So I've just used the chain rule within the quotient rule, and that happens a lot. You're just using combinations of these different rules to be able to differentiate stuff. Okay, so I've got my u and my v there. I'll just do my little tick to remind me about my order, and then let's go for it. So it's going to be messy, but let's do it. Okay, so f dash of x. So is equal to that first one. So I'm just going to rewrite that now as square root of x squared plus 1. And that's going to be multiplied by 1 over x. Okay, so that's the first bit. First bit there. Take away that one times that one. And so what have we got? We've got minus log ex times, well, that half times that 2 in there will cancel out. So I'll just write it as x bracket x squared plus 1 to the negative half. All right, that is disgusting. And then on the bottom line is just v squared. So it's just that thing squared. So I'll just write x squared plus 1 to the half, all squared. Okay, that half was pretty bad, sorry. Probably won't better read that. That's slightly better. Squared. Okay, let's see what we can do to simplify this, because we've got some fractions. We've got, we've got this horrible negative half power here. They've got that 1 over x. That will tidy up nicely. So there might be a couple of things that can simplify here. So let's just have a look at it and see what we can do. So I'm just going to rewrite this as x squared plus 1 over x. And then similarly, it's going to be minus x log ex. That's power negative half there. Means that that's going to be the square root of x squared plus 1. So we've got that there. That's all the top line stuff. Will it simplify into something nice? Probably not really. That looks pretty gross. I've made some horribleness from it, but at least those things cancel out. So that's just going to be x squared plus 1 on the bottom line there. What can I do? I could probably put those two fractions together. So I'm going to put this fraction and that fraction together on the bottom line. And so what will that become? I'll leave it like here for a second. So if I put them together, I'm going to have x and then x squared plus 1. You have to excuse having the triple decker fraction here. I'll show you what happens in a second. So if that goes to that, then we multiply. We sort of like essentially do a bit of a cross multiplication. So it's going to be, if you don't follow this, I apologize, but if you go and do it in your own time, that times that. If we put them over the same fraction, and so that'll get rid of the square root, so that'll become x squared plus 1 over that, because we need to multiply the bottom and the top line by the square root of x squared plus 1, and then we need to multiply that by x, so that'll become minus x squared log ex. Now, what we have here is if you divide top and bottom lines here, if you have 2/3, right, divided by, say, 6 or something, that's equal to 2 over 18. And so effectively what we're doing, that's the, that's the 2, that's the third, that's divided by 6. And so we can just multiply those two quotients down there. So the top line will be x squared plus 1 minus x squared log ex. On the bottom line, it'll just be that multiplied by that. And that gives us, well, that'll give us an x, right? And then that's x squared plus, that there is x squared plus 1 to the power half. That one there is x squared plus 1 to the power 1. So if I multiply those two together, we get x squared plus 1 to the 3 over 2. And that's probably the nicest I can leave that. I could factorize the x squared on the top line. In fact, we probably should. I just noticed we'll cancel that out. So that x will cancel with that x squared. No, then there's that 1 there. Oh, I think I'll leave it. I think I'll just leave it like that. I can't see any clear way that will be simplified. So let's just leave it there for the video, for the sake of the video. That was a nasty one with some simplification in there. Pretty horrible. Hope that made sense. I'll see you in the next video.